Hello everyone. So today we are going to solve this Leetcode question number 238, which says product of array except self. So let's go through the problem statement quickly and understand. So we are given an integer array nums and we have to return an array answer such that the answer at any particular index is equal to the product of all the elements present in the given array except the current index element, and we have to write an algorithm which returns a result in big O of n time complexity and without using any of the division operation. So what they actually mean is, so let's take this example 1 2 3 and 4, where we cannot find out the product of the entire array and then keep on dividing the elements when we go to a particular index. So that is prohibited. We have to find out a technique which runs in big O of n time complexity. So let's quickly jump on to understanding this problem and we'll take a look at the example which is given. So the first example which is given to us, it's an array containing 1 2 3 and 4. So over here we have to calculate an answer array for each and every index. So let's say how we are going to do it. So first of all, it is given that, let's say we want to find an answer at index 0 with element 1. So what we are going to do is we have to calculate the answer at this index by calculating the product of all the elements which are present in the array except 1. So we are not going to include 1, we are going to include all the elements present in the array and we are going to find the product of it. So 2 into 3 into 4, which is equal to 24. So answer at index 0 will be 24. Now let's jump on to index 2. For index 2, the answer would be product of all the elements except that element, which will evaluate to 1 into 3 into 4, which is equal to 12. So answer for the first index will be 12, and then let's move on to 3. So for 3 it would be 1 into 2 into 4. So we are excluding 3 and the answer at index 2 would be 8. Likewise for 4, so this is for element 2, this is for element 3, this is for element 1, and for element 4 it would be 1 into 2 into 3, all the elements except the current element, which evaluates to 6. Now answer at third index will evaluate to 6. So the answer array would look like 24, 12, 8 and 6. So this will be our final answer. Let's quickly see the another array which is given to us. Another example. So the elements in the array is -1, 1, 0, -3 and 3. So here the product, so using the same algorithm, what we are going to do is we are going to exclude this element from the product and we are going to calculate the product of all the elements except this element. So here, since 0 is there, so the product would be 0. Likewise, for this particular element, we are going to multiply -1 0 -3 and 3, which again evaluates to 0. For this element, it would be -3 into 3 into -1 into 1, which evaluates to 9. Likewise, for these two elements, the product would be 0. So this forms our final answer array. Now let's quickly see how we are going to solve this. So in the question itself, if we see, we are given a hint where we can use the prefix and suffix sum. So let's see how we are going to make use of prefix and suffix over here. Let's write down the example given in the problem statement. So so eventually prefix means anything before the current position, and suffix means anything after the current position. So that is the general terminology that is there for the prefix and suffix. So let's say for we consider this element 2, so the prefix would be all the elements before 2 and the suffix would be all the elements which are present after 2. So what we are going to do over here is we are going to calculate the prefix array and suffix array. So here for let's see this example where we are evaluating the answer for 2. So answer for 2 would be all the elements which are present, the product of all the elements which are present before 2, and product of and suffix would be product of all the elements which are present after 2. So eventually what we are doing is we are calculating the prefix product and we are calculating the suffix product, and we are multiplying them both. So here the prefix for 2 would be 1 and suffix for 2 would be 3 into 4, which gives us the final answer for 2 would be 12. So this is how we are going to solve using the prefix and suffix array. So since it is given that we have to use only big O of n time complexity, so let's take a look at the algorithm that we are going to use to solve this particular problem. Okay. So what we are going to do is we are going to make use of prefix and suffix arrays, and prefix array and suffix array we can declare. And initially the prefix array would go from first index to last index, and suffix array would go from second last index to 0th index. Why we are doing so? Because prefix always will be starting from the first position and suffix would always be starting from the last position, because that is how the basic definition of the prefix and suffix works. And then we are going to initialize the first index prefix of 0 with 1 and then suffix of last index n minus 1 as 1. Why we are declaring it as 1? Because we are dealing with products, right? So anything multiplied by 1 is the number itself, so that is why we are initializing prefix at 0th index as 1 and suffix at last index as 1. And then what we are going to do is we would be running a loop for prefix from 1 to n, and then we are going to evaluate the prefix sum, which would be prefix at the current index would be the prefix at last index. Last index would be index minus 1, the previous index, multiplied by the number at the previous index. So this is how we are going to calculate the prefix, and for the suffix we are running a loop from n minus 2 to 0. So suffix at any given index would be suffix at the next index, index plus 1 multiplied by the number which is present at index plus 1. So for the prefix it is always the previous element, that is why we are calculating the index minus 1 at both the places, and suffix is always the next element, that is why we are calculating index plus 1. And lastly, what we are going to do is we are going to run a loop from 0 to n, and then we are going to calculate the result at any given index, which would be equal to the prefix product at given index multiplied by the suffix at given index, and then this would be our final answer which we have calculated, and then we are going to return the result. Let's quickly summarize. So we would be taking one prefix array and one suffix array. Then prefix array would be running from 1 to n, and suffix array would be running from the second last index to the 0th index. We would be initializing the first elements of the prefix as 1 and the last element of the suffix as 1, because we are dealing with products. So, and that is why we are initializing the first index and the last index as 1. And then what we are going to do is we are going to calculate the prefix sum from 1 to n. Prefix at any particular index would be prefix at the previous index and multiplied by the element at that particular index, and suffix would be suffix at the next index and number at the next index of the current index that we are traversing. And then we are going to calculate the product, the R resultant array, which would be equal to prefix at given index and suffix at given index, and we would be returning that result. Now let's quickly jump on to writing this code as per this algo, and we'll see like how we are doing there. Okay, let's write down the code quickly. Let's evaluate the length. The length would be nums dot length, and then we would be initializing the prefix array, and then we would be initializing the suffix array. Then we are going to initialize the prefix at 0th index is equal to 1, and suffix at n minus 1 index is equal to 1. Then what we are going to do is we are going to run a loop for prefix, and it will be starting from index 1 and running till the length. Increment the index, and then inside what we are going to do is we would be calculating the prefix at a given index, which would be the prefix at index -1, the prefix at the previous index, multiplied by the element at previous index. So this is how we are going to calculate the prefix. And for suffix we would be running another loop and starting from the index n-2, which would be the second last index, and running till the 0th index, and we would be decrementing the index in this loop. Then suffix at any given index would be evaluated by the suffix at the next index, which would be index +1 multiplied by the element at the next index, which would be index +1. So now we have evaluated the indexes. Now we have evaluated both the prefix and the suffix arrays. Now let's initialize a resulting array which would be of size same as the given array, and we are going to run a loop from 0th index till the last index. And here in this loop we are going to evaluate the result for all the indexes in the array. So the result at particular index would be the prefix at the given index multiplied by the suffix at given index. Now after exiting this loop we would be having our resultant array fully populated with the answers for all the indexes. Let's quickly try to run this. Okay, both the test cases are passing. Let's submit this. Yeah, all the test cases are passed. Let's see the time complexity for this particular solution. So now we are traversing all the arrays, like both the prefix and the suffix arrays, one by one, and we are only running the loops like separately. So the time complexity would be at max, would be big often, because if you see this particular loop here, we are traversing from 0 to n, and here we are traversing even less than n elements. Here also we are traversing less than n elements, so the time complexity overall would be big of n. Yeah, okay, that's all for now. See you in the next video. Thank you.